Hello and welcome to today's Squish Coco release webinar. My name is Florian Torg. I'm a technical sales engineer with FrogLogic, and together with Sebastian Paulsen, we are excited to welcome you to this special edition of our weekly webinars. Today we'll introduce the unique main features of Squish Coco, which is the function profiler. We'll also mention all other features which have been released as part of Coco 5. We will have a question and answer session at the end of this webinar. You're muted right now, which does not mean that you're not able to ask your questions. In the GoToWebinar client, you will find the option to enter questions, which will show up at our end, and we will collect those questions and provide you with answers in the Q&A session at the end of the webinar. All right, so I think we are ready to go. So Sebastian, who's one of our Coco developers, was so kind to join this webinar to present you Squish Coco Release 5. Sebastian, are you ready to start?
I'm ready to start. Can you hear me?
Yes.
Okay. Good morning from me too. So let's start. Okay. I hope you can see my screen. Let's start with the general overview. What's in this webinar? First step, I would like to introduce you into Squish Coco. So give a little overview. What is Squish Coco? Just a little recap of what you might already know or some new information for you. Then I will go into further detail of the function profiler, which is, I guess, the biggest new feature in our 5 release. And in the next step after that, I will continue with general changes, and we will discuss the release notes. So let's hop right in and go for a little intro. So which languages are supported by Coco, which is basically what you might already know. We support C, C++, Tcl, C#, and QML. All of those work right off the box. There's not much to adjust. Furthermore, we support the main compilers and much more. It's just in this case we don't want to mention them all here, but basically we support all of those compilers that are out there. We just maybe need to adapt a bit. Yeah, the question on which platform Coco runs is basically everything where your code runs and you have enough space. Sometimes on embedded devices this could be a bit tricky, but always possible. Yeah, next about how our coverage, or which coverage levels do we support. So here on the right side, you can see the different levels of coverage we support with our
Sebastian,
tool.
I think there's a problem with your presentation. I'm still seeing the first cover slide, so it might be just my client, but maybe you can double check this, please.
Wait. Yeah, sure.
Yeah, that looks much better.
Oh, nice. Okay. So here on the right side, thanks for mentioning this. Yeah, where was I? So basically, these are all the coverage levels we support: function coverage, line coverage. You name them basically. And if you're interested in certifications like ISO 26262 for developing cars and so on, MCDC might be interesting for you. So keep that in mind that we support this one as well. Yeah, next step, how does Coco work? on the left side, we have here our normal instrumentation, or normal compiling rather, of your source code into the binary. And on the right side, we see that in the preprocessing, or better, after the preprocessing step, we edit a little bit, or add a little bit of code to the preprocessed code, and then at the linking process here down here, we generate a CSMS file which holds all the necessary information for us, which will be needed further with the CSMS file, a CSX file. So sorry, you will see this in the next step. The CSX file and the CSMS file are needed basically to get the informations of which functions are executed and which parts of your applications are executed. Yeah, these CSX files are generated when you execute your test, or in this case, you can think, or in other cases, you can just print them out while you run the program. On embedded devices, there might be the not the option to terminate a program. So writing out the coverage data in a different way was necessary for this. These two go, the CSX file and the CSMS file, go into the coverage browser, where we can analyze basically what has happened, which parts of our application has been covered, in which not. So let's start with the necessary parts for the release, the 5 release, basically. So in the first step, I would like to introduce you the function profiler, which is the main thing in our release, and it's basically, and I will show you how to enable the function profiler. I will show you how to open it in the coverage browser and explain a bit about the columns. Okay, so how to activate this? So here we see the command line parameter we need to set, or we can set this at the coverage args arguments, basically in the environment as an environment variable. These two options, or these options, are there. And then furthermore, you can adapt the CS function profiler to two different modes, all, where it actually says like all data to the functions, and the second one is skip trivial, where it skips functions like getter, setter, basically every function which is only a line, because these tend to add up in the function profiler and might slow you down. So keep that in mind, that you can switch between those two. How to open the function profiler in the coverage browser? There are actually two ways. Click on one of the header lists here in sources, for example, and click or right click, and then you can enable the function profiler, or the other way, normal, like you would know it is via the view, you can enable the function profiler. And to open this, okay, so there are some columns at the start, and the first one is basically the function name, which gives you the reference to the function, and the next column is basically the total duration, how long does all the times, or all the accumulated times add up to a time, which is basically representing here. And the count is basically how many times the function has been hit. That's just plain simple. And the mean duration is how long does each function take in in meantime. Okay, so this is the normal setup where you would start, but I will show you later on that you can customize some of the columns as well to adapt your needs. So let's hop right into the function profiler in action. And I would like to show you first how to enable it, and second, I have prepared a little program here where we can test our little function profiler and show and have a little showcase of what to do with the function profiler and what benefits you have from it. So I will jump right in. So I'm on a Linux here, so you will see some command line action here. So here I have a little project which is basically a little parser. I will show you in a brief moment here what this parser it does, and basically we have here our little parser program which we can execute. And these executions, when you execute it, you have to enter an expression, which could be 3 plus 3, for example, or 6 plus 7. Uh, Basically, you name it. And since here are various different parameters can be given, basically, we need some good tests. So there are actually some tests here already prepared. I will have to make them as well. The instrumented script here is basically instrumenting the code and giving or creating already the CSMS files here. Okay, I will create now or make the unit tests. This will take some seconds. I will clean this up afterwards. So yes, now it's way much more instrumented. We see this on this CSMS file, and here our newest addition to this folder, the unit tests. We can execute them and run some tests on the parser. And if you might want to look closely, this might take a little second here. Wait, I need to. This last test takes a little second or a little bit of time, which is oh, I don't want to open it. I want to open it myself. I have it already in the background, so you might this is why this pops up. So I opened already the coverage browser here, and I want to open. No, I don't want to save this. Yes, I don't want to save this. I want to open the parser example here, clean, and yeah, you can see here these are the functions basically of this CSMS file. The simple they are it's basically what you are already known to. Coco can include or yes import now the execution data we generated with the unit test. It's not our execution which we want to import now. We want to import the unit tests in this case, and we will generate or basically get our coverage data from our functions here. And we see some informations about our coverage and stuff like that. Here, down here, you can see those tests we already saw earlier here are always already listed here. And now we want to open the function profiler, which you can do here in this case. And we can actually see, I will make this a bit bigger so you can see better. Don't need the sources anymore. Here you can see how many functions, or here you can see the function name, as I already mentioned. Here you can see the accumulated time they took. So basically, when you see to upper has been executed, which time is it? Yeah, a big number, and the mean time of the function is 0. What is it? 0.1 microseconds, and the accumulated time is 5.89 seconds. So what do we want with our function profiler? What can we do with it? So basically what we want to do is find functions which make the programs a lot slower. So what you are looking for, or is in our case here, is something which is growing differently than other things. Growing in a way that this takes one amount of time, and the second one does, or the function which is invoked from this takes a lot longer. So let's check. We have these two cases here, the 1,000 and the 10,000, basically, and we can compare them with the execution comparison analysis. So basically what we want to do now, when we enable it, we can see the function profiler changes, and now we have total duration reference, count reference, mean duration reference. So we can see, actually select here in this column the test we want to compare to the other tests. So we want to compare the 1,000 test to the 10,000 test here in this case. And we can actually see, yeah, in this case we don't see actually, but we can see here how much time did they took, how many times have they been invoked, and stuff like that. So when we see the count numbers, let me just have the count numbers. It's easier this way. Okay, so one thing you might notice here, so there is several informations when you hover over this line, so you don't have to see all the columns basically, but I spread this so wide that you can actually see them. We can see here that we have 1,000 times the add function in the reference, which is basically our test add variable 1,000, and the 10,000 is basically the other one. But we can see here that the to upper function here, in this case, takes is not factor 10. It's not 10 times bigger than this one, but it's actually 100 times bigger, if I recall correctly. Yes, yes, it's 100 times. So we need to adapt this so we can actually see, oh, this function is invoked way more than the other functions. We might want to tweak this function and optimize this function to be way faster. So let's do this. Let's make this function faster. So what I want to do now is to save the current execution, which is then saved into the, wait, I will clean this for you, which is now saved. Everything is saved in the parser.csms file. And I will move this one now to have this one to compare it to the new execution. So I will need to move the parser command to old comparison. So I have this right next to it, so I can compare to it. So what I want to do now is actually change the command lines I need to change, or basically not command lines, but the source code lines I want to change. So for our convenience, I already prepared them in a little example here. So what I want to do now is I can basically git stash pop, which is basically I will clean, make it clean. That's easier for you to spot. So I have now the C++ file and the header file replaced with faster ones. So what I can now do is actually see I have improved this, but how much have I improved this? What I want to do now is basically run or make the program again and run the test again. So we run the make and the make test, and I will use some CPU power for this to make it faster. And now we want to run the test. So we run the test again. So we change the source code to what we think is faster than the other one. And we execute our test. I don't want to do this. I will show it you later. So what you might notice from the last time, this took way less than before, but actually we want to compare this to the execution before. So what we want to do now is basically I will stop execution report and I want to open the function or the parser again and import the coverage data again. So we open the parser again. We see our, we want to load the unit tests. We execute it again and we want to import them again. So what I want to do now is save, and I can see here that these tend to be less lower than the other one. But actually, we can compare the two executions or the two databases basically, and we can say select compare with. And in this case, I will navigate to the webinar and parser example here and compare it to the old basically source code or the execution with the old source code. So we load this and we can actually see the columns here have changed slightly. So I will make it bigger here in this case. We can actually see these ones are identical, and we can then further see there are different codes and stuff like that. So I will just do some. Yes. No, this one is probably a bad case. But wait, where is it? There it is. The add function in this case. So here you could see that the add function takes 7.73 seconds, or is 7.373 seconds faster than the one we had before. So actually you could see here the improvements of our code, or of our changes to the code. We can basically identify which functions tend to add up to our execution time, and if we change them, how much did we change them? How much time did we save, basically? Yeah, that's basically our function profiler. And here on the top side, you can see different columns. You can actually adjust these columns. So you can say, I want to have some here, or I want to have this file name, and are they modified or not, and I can have a ratio or not just difference. It's there are plenty of information here which you can friggle around with, and to optimize your setup or what you need for your optimizing of code. Yeah, that's our function profile. I hope you like this little example for this stage, and I will continue now with the next step in my on my list is basically the release notes. I might have I have closed them on. Yes, that's perfect. Sorry, I closed them. I had them open all day. So here you can see in the bottom here you can see our release notes, which are the new features of our code. And here you can see all the informations, or basically all the changes. So let's tackle a bit of the main changes here. The newest feature, the function profiler, you already saw in the last minutes of my presentation. This one is, yeah, the biggest change. There are furthermore more little features in the coverage browser. There's the possibility to compare different matrices between two releases. For example, the McCabe matrix, or yeah, the McCabe matrix, which you can compare between two releases, which might come in handy because you can say, yeah, the complexity rises of the code or lowers. And there are some more minor changes to the coverage browser, some bug fixes, and the option to exclude all instrumental files from the patch analysis, which you already know, probably already know. The patch analysis is to compare different versions of your code. Basically, what we've been doing with the parser, we had the old code with the old stuff, and the new stuff, compare them. But in this case, in the case or the showcase, we were focused on the time they have been executed, and the patch analysis is basically about the coverage. Okay, so furthermore, the coverage scanner has now integrated support for the ARM compiler, which is pretty convenient, and the function profiler as well. As you already see on the one of the first slides there, you have the information on how to activate the function profiler in your project. There are some minor changes to the report and the edit function, and there's for some of you might be interesting our license server, which is basically holding or managing the floating license, has a more convenient way of storing the data in the etc folder. And last but not least, we have a better integration with Squish, our main tool, and see this here. There is a whole blog article about this. If you want to see or read more about this, you can find this on our website, and on the right top side there is the blog button where you can see all the necessary information and have more information about the further releases and how-tos. Okay, so let's head back to the presentation here, and next on my list is the questions parts. Florian, are you here?
Yes, so here I am. So yeah, first of all, thanks a lot, Basti, for giving us an introduction of the new features. I think it's quite interesting to see that Coco more and more becomes a code analysis tool, and it's not just a code coverage analysis tool anymore. So it adds many features which yeah, other code coverage tools definitely do not have. So yeah, so that was pretty interesting to see. First of all, we are always interested in your suggestions for webinars. So this one was just about the new features of the tool, but in general, yeah, we do have regular webinars on our tool Squish GUI Tester as well as Coco. And yeah, if you're interested in a specific topic, feel free to post that into the questions section of the GoToWebinar client. So that was just a short request from our side. And we do have some time for questions now. So yeah, there's this question setting or a section in the GoToWebinar panel. So far, there are no questions in there. We would be really more than pleased to answer your questions, whatever it is, even if it's not really directly connected to Sebastian's presentation and the Coco 5 release. But it seems that Sebastian was able to answer all your questions. If something shows up after this webinar, feel free to get back to us. You can reach us through our website by sending an email to squish@froglogic.com, or we are also available in social media channels. So if something shows up, don't hesitate to get back to us. We would be more than pleased to help you. Also, I'd like to mention that we do offer free evaluation versions of Coco, as well as the Squish GUI tester, as well as our new product Squish Test Center. So if you're interested in that, feel free to request that through the form on our website, or just drop us a line, and we would be pleased to send you login credentials. So there's a question coming in. We would be interested in having general presentation of Coco. Oh, so yeah, of course that's possible. We would be available for that. First of all, there frequent webinars which you will find on our website. Of course, I'm not quite sure if the next one regarding Coco is going to happen soon, next week or something like that, because we also schedule webinars for the other tools. However, if you would like to see the general features of Coco and the code coverage features, we can schedule a one-on-one meeting with you to give you a personal presentation. So that's no problem at all. So just send us an email asking for that. If you like, you can mention my name, Florian Turk, and we will get back to you to schedule such a session. All right, so I guess that's it. No other questions. So thanks a lot for joining today. I hope it was interesting for you to see what we added to Coco. Thank you, Sebastian, again for giving this nice presentation. Thanks a lot for joining today's webinar. We would love to hear back from you. So yeah, waiting your messages. So thanks a lot, and stay healthy. Bye bye.
Bye bye.